All right, let's talk about one of the oldest kitchen hacks in the book. You know the one. You've got a pot boiling away, and you lay a wooden spoon across the top to keep it from boiling over. It totally feels like magic, right? Well, today, we're going to pull back the curtain and look at the real science behind this amazing little trick.
Oh, we have all been there. You're making pasta or potatoes. Everything is going just fine. You turn around for, a split second. Maybe you go to grab the salt or check a text, and that's when it happens. Absolute chaos on your stovetop.
You hear that sound, that angry hiss, and you look over, and this tower of starchy foam is climbing up the sides of the pot. It's about to spill everywhere and make a giant, sticky mess. It feels like a race against time, but what if I told you a simple tool can stop it dead in its tracks?
And that tool is, of course, the humble wooden spoon. You know, it's one of those things passed down from our parents or grandparents, and it's so well known because, it really, really works. So the question isn't if it works, it's how it works. So what is actually happening on a scientific level? What is this spoon doing? Is it something special about the wood or the shape? Well, let's get into it and break down the two main reasons this trick is so darn effective. Okay, so our first explanation is all about chemistry. It has to do with the unique properties of wood. Turns out, your simple kitchen spoon is basically a bubble's worst nightmare. Here's the core idea. Wood is naturally hydrophobic. That's just a fancy science word that literally means water-fearing. So wood doesn't like water, and that property is absolutely key for what's about to happen. So when we say it's repellent, what we mean is that the dry surface of that wooden spoon is a really unstable place for a bubble made of water. The second a bubble touches it, its surface tension just shatters. You can think of it like popping a balloon with a pin. Same idea. So you can picture the whole process, right? This column of foam starts to rise up. The bubbles at the very top hit that dry, water-fearing wood surface, and poof, they're gone. They just collapse. And this sets off a chain reaction that breaks down the foam underneath. But wait, that's only half the story. All right, let's move on to reason number 2. This one takes us out of chemistry and into the world of physics, and it has everything to do with a big, big difference in temperature. Think about it. On one hand, you have boiling water that's a sizzling 100 degrees Celsius, or 212 Fahrenheit, and on the other hand, you have your wooden spoon, which is just sitting there at room temperature. That huge temperature gap is the secret to this second effect. You see, those bubbles boiling up aren't just filled with air, they're filled with super hot steam. And when that steam comes into contact with the much, much cooler surface of the spoon, something really fundamental in physics happens. And that something is called condensation. The spoon basically acts like a heat sink. It just sucks the energy right out of the steam. As soon as the steam loses that heat energy, it can't stay a gas anymore. It instantly turns right back into liquid water. So, just like before, you get this really simple but powerful chain of events. The hot steam from the bubble hits the cool wood, the steam immediately condenses back into water, and the entire bubble structure just collapses. So, after looking at both the chemistry and the physics, the verdict on this old kitchen hack is crystal clear. It's not just some old wives' tale. It's a totally confirmed scientific phenomenon happening right there on your stove. So what you've got is this amazing 1-2 punch. First, the chemistry. The repellent surface of the wood physically pops the bubbles. And second, the physics. The cool temperature causes the steam inside to condense, collapsing the bubbles from within. And that's really the main takeaway here. That wooden spoon you have isn't just a spoon. It's a 2-in-1 scientific tool. It's a physical barrier that breaks bubbles, and it's a thermal device that collapses them. It's just a simple, elegant, and super effective solution hiding in plain sight in your kitchen. It really makes you wonder, doesn't it? Our kitchens are just full of these little bits of folk wisdom that are actually based on some really fascinating science. So, what's the next piece of kitchen magic you think is just waiting to be explained?